Hello, and welcome to our Analytics and Data TechCasts. My name is Dan Vlamis. I'm joined here by my brother, Tim Vlamis.
Hi, everyone.
So we're going to be talking today about leveraging Oracle Analytics Cloud for analytic warehousing. We'll have a few introductory remarks, and then we'll get on with the show.
Yeah, and I'm going to interrupt Dan continually throughout the TechCast today.
So that gives me
And
permission to interrupt him as well when Tim is presenting most of the content. So go ahead and get the next slide, Tim.
Yep.
So we've got some helpful links in here. This is especially for Oracle Analytics for that portion. We'll put that into the chat so you can find that material, but there's also, we'll be talking about Autonomous Data Warehouse, and I'll see if I can find a link for that with you as well. This is in a series of TechCasts. Analytics and Data Oracle user community has been presenting on these related topics for, 5 years now. We've got a bunch of them out on our TechCast archive. And you'll see, we also want to encourage you to submit your own ideas for TechCasts. You can submit those at andouc.org/TechCasts. There's a place where you can submit your own topic. We would love to feature you and have your topics that you want to talk about in these TechCasts. That's where we get this great content, and we've been doing it for 5 years now.
Hey, Dan, in a reversal of roles, I'm actually going to be hosting Roger Cressy later this month, which I'm looking forward to, giving him a hard time.
Okay.
And then Bud Endress is joining us this summer to talk about analytic views, which I'm pretty excited about.
Well, that's going to relate directly to some of the topics we're going to talk about today. So
Yeah.
we got this thing scheduled, and we can highlight Bud talking about analytic views.
Yeah.
There's a whole schedule coming up. You can also support us by visiting our store, Analytics and Data, and join our community. We've got several ways to join. We'll put those links in the chat as well. I'd also encourage you all, we are a community, so I encourage you to say hello, where you're from, and network with each other as well. We'll have a chance also, if you have questions, please put them in the Q&A widget, and we will handle those as we go along. And if you put something in that's directly related to what Tim's talking about, I'll probably interrupt him. Otherwise, we'll hold them to the end and go through today's topic. So
Dan, big news from our side, yeah?
Yeah.
We joined Huron as of the first of the year. So go ahead, Dan.
So yeah, we're pleased to have Vlamis. Tim and I were with Vlamis Software. Now we're with Huron as of January 1st. So Tim and I co-over as directors. All of Vlamis came over. This is just a little bit about Huron. Large consulting company, $1.4 billion in revenue, listed on NASDAQ and headquartered in Chicago. So real pleased to be joining that organization, and that's where Tim and I are with now.
Yeah, Dan, I think there's about 1,000 people total in the Oracle practice there. So we are learning a lot. But
it's good. So with that, we'll get into today's topic. We're going to talk about analytic warehouses and how we expose them through Oracle Analytics Cloud, and how we kind of our preferred platform for building them at this point is on the Oracle Autonomous Data Warehouse. So I'll go through
Dan, I think the key thing here is that there's a traditional sense of data warehousing, right? And a lot of us have been in this space for decades. And originally, as we started, if you go back to Kimball and there was the idea of the single source of the truth, and basically they were trying to be comprehensive, right? But in any case, they were designed for storing all the data. And I think the difference is we see analytic warehouses as designing for answering queries. And that's the fundamental difference. It's all about processing and, in essence, having a processing layer as opposed to, a big store.
Right. So
yeah.
In this slide, we go through kind of a difference between them. Data warehouses are there for storing data. we think of analytic warehouses as especially there for retrieving and analyzing the data. That's where we put the emphasis.
Yeah.
A lot of data warehouse stuff was done for ETL. And this is the way, and we emphasize this just because a lot of the consulting community that we talk to and data professionals still focus on how to get the data in, and it affects how you end up structuring the data and how you end up looking at the data. And people focus on what data they're bringing, and we like to start from the analysis that we want to do. Often we start with prototypes instead. There's an emphasis on the provenance of the data, where the data comes from in a data warehouse. We focus on the use of the data. How are they going to do it in often a prototype? We also grow the data with analytic workflows, calculating additional measures, sometimes that are too slow to do on the fly. Sometimes they are virtual measures that are calculated on the fly. We also focus on the most important data in an analytic warehouse, as opposed to the traditional approach was we're going to put everything in the data warehouse. Now we have other techniques with data marts and with data lakes that hold all the data. We also can have complex aggregation strategies. In some cases, the analytic warehouse is really a pointer mechanism that points to other data that is stored in other locations that's outside of the data warehouse, as opposed to put everything all in one instance. Some of these, sometimes they're federated.
Yeah, Dan, I think of this as more of a data factory, if you will.
Yeah.
So yes, you have to bring the data in to be able to process it, but this is really about the assembly, organization, and processes that create data and use data and make it available, as opposed to kind of bringing in raw data and storing it, you know?
Yep.
I'd also emphasize that if we had a better term than warehouse or lakehouse that incorporated this idea of manufacturing or creating the data, we would use it. So if you guys have ideas on the better language, please put it in the chat and let us know so we can update our stuff.
Go ahead, Tim.
Yeah, so really what we're talking about is the logical structuring of the data, specifically as it's designed for analytic purposes or for analysis, for use by analysts. And this is where we see, you know, kind of the whole data munging, data organization side of OAC converging with the idea of what we have traditionally referred to as analytic warehousing. So when Dan started out, he was, you know, Mr. OLAP. And so it's always been about how do we build multidimensional structures within, you know, the warehouse? How do we use it? How do we organize it for responding to queries? So Dan has really been doing this for, gosh, 30 some odd years now, huh, Dan?
Yeah, long time.
Long time. So, but that's how we see this conversion taking place. The distinction, again, between processing engine and storage layer, comparative values are really important so that we have context and we are able to draw insight from data. And this also goes with the emphasis on relationships, hierarchies, structures, ontologies, if you will, in terms of how this data is organized, such that, you know, how it relates to one another actually provides value in terms of how it's used. It is about being fast. We are dealing with more and more data every day, as everyone will acknowledge. And then what we really are incorporating is this conformed, you know, data processing kind of idea where we don't have silos where we do different kinds of processing. If we want to do geospatial processing, we do it in the same layer as we do our machine learning, as we do our vectors, as we do, you know, whatever other kind of multidimensional structures, whatever else, so that we're not moving data around. We want to actually bring the algorithms and the processing to the data rather than moving data. I think the cloud, Dan, kind of speaks for itself, right? This is all about how do we, think about the data more and its use cases and less about, the hardware and all those kinds of issues. Now we have a lot of architectural issues in the cloud that we can go into. I don't know that that's a topic for today, but
Well, the big thing I want to mention from this is the last bullet, the scalability.
yeah,
There was a huge emphasis on when data warehouses were first put together in that you had to plan for what machine you were going to put it on. Now, most people in modern places are putting this in the cloud, which allows more scalability, or they're using virtual machines for doing this that allows you to scale as necessary. And that affects the planning of this because you can do some of that later.
right. Dan, I think there are some things as we're going through this and we, work with engagements with clients and whatnot, some of the larger enterprises. What we go back to is what are the key questions that we should be asking as opposed to kind of the typical IT questions, if you will.
Yeah.
All right. And so when we're thinking about this, we want to think of it from an architecture, from a strategy perspective. This should really, in my opinion, say for data strategy and architects.
Yeah.
But we should start with what are the business issues or the organizational problems that we're trying to solve or address? That's really the key question. And that will lead us to better answers in terms of architectural issues, as well as data organization strategies, as well as processing strategies. Where do we do it? That kind of guides our thinking. The use cases that provide the most value the fastest. In most of our engagements, we try to always have a quick hit deliverable so that we get kind of the support from the organization before we get into the overall, major endeavors that can sometimes take months. So that is also something that we find being nimble, being agile, kind of, that modern approach is really important, and you just have to take it. Otherwise, the waterfall stuff just, things move too fast. By the time you get to the end, everything's changed.
Well, and one of the things we do in that is we try to get support from high-level executives doing that,
Sure.
show some value quickly, even though we haven't dotted all the I's and crossed all the T's. And you just have to have the confidence that you'll be able to design it the right way, come back and figure out exactly how are we going to make this so updatable. But sometimes we'll take shortcuts in exporting out a flat file or something like that, just to be able to show this is what we need to do. The reason is that allows people to say, what do they want to do with the data that informs, comes back and influences as we create those structures. We need to know that up front.
Yeah, absolutely. This ad hoc versus presentation in
Yep.
terms of affecting the design, I think we recognize that we have to do both very effectively. And, sometimes we try to use the same structure. Sometimes we actually design different ones. And this basically means, how much selection criteria are we allowing on the front end versus, no, this is just designed for consumption for an audience of consuming a result set. Now we can think of this in terms of developers as well as kind of, if you will, analytics consumers, right? Who is your audience? This is something else that we want to, when we're designing a major enterprise system, the audience is going to be internal, right? The eventual audience may be, a business user, line of business. We may have very, very different levels in terms of the users and whatnot. But thinking carefully about the use cases is really what we're trying to drive at here. Casual versus everyday, how skilled, how much, we'll talk about this when we get to some of the interfaces, Dan, in terms of, what we're seeing and what we applaud from Oracle is that they are both developing kind of the, let's say, the scripting code first kind of interfaces for business users, as well as, you know, the no code, low code GUIs, which personally I would say I'm a fan of. I hate counting parentheses and commas. So
Yeah,
there
right.
you go. And then we really need to think of where are the users in terms of, you know, the consumption cycle. Are they using the warehouse to develop other systems, or are they using it to work directly with the data and present it to business users? How are they using it? You know, also, you know, classic reporting is about presenting raw numbers. You can think of it as kind of reading. So reports are read, analytics are observed, and people get insights. So that's one of the kind of the key distinctions is this from some kind of source system that we're presenting something to be read, or are we presenting kind of new insights that we expect people to understand and to sense? The reason we put this up for Danford is the data created by transactions or analysis is really, we're thinking about source systems, we're thinking about efficiencies, we're thinking about also some of the cleanliness of the data, that kind of thing. Because if this is coming from a transactional system, you know, then we have to recognize the complexities of modeling it, right?
Well, and that's also to emphasize that some of the data is created by analytic workflows.
Yeah.
Something that actually goes and does forecasting, a statistical forecast that doesn't run necessarily on the fly. Maybe you run that in an overnight process.
Yeah.
And sometimes you're doing binning calculations that are not necessarily done on the fly.
Yeah, exactly. So, and I mean, people can read the rest of these. The data scanned by humans or scanned by algorithms. Really important, just in terms of, you know, the use case, and or does it come from humans? Does it come from algorithms? You know, a lot of the IoT data is pretty clean. A lot of the data that's entered by humans in an ERP system, not so clean. Not
Well,
so
some of this will
consistent.
be clear also once we get to the demonstration.
Let's move on. This is kind of here just for, you know, if you're working on your architecture and you want a basic framework to think through, how do we think about this data in a comprehensive way? We've adopted the 5 S's from the Six Sigma stuff for thinking about our analytics architecture. So sorting, you know, what we basically say is, don't try to organize all the data. Pay much more attention, kind of an 80-20 rule on the valuable data. So spend 80% of your time on 20% of the data, if you will. That's the data that's most valuable. And the rest, you know, you can be a little more casual. The idea of, you know, having a good governance process is really important. So your naming conventions, those kinds of things, in straightening, sweeping, getting rid of old stuff, really useful, and standardizing and having patterns. So we think of this in patterns in terms of what patterns do we help create, what do we reinforce, and how do we build out systems so that there's an expectation and consistency to it. You don't have
That helps also when new people are coming on board. That's something that we find is often neglected. Everybody says,
Yeah.
well, everybody knows where stuff is. But
Yeah,
then
they
as people naturally rotate through, it's hard to explain stuff.
I'm laughing because I still don't know where everything is in my new computer. Anyway, and then kind of the, you know, business processes around this stuff, I think is pretty straightforward. Dan, I don't know if everybody wants more PowerPoint slides, please put in the chat.
Yeah, if you want
PowerPoint, you don't want demo.
yeah, we'll continue with that. We actually have some more slides. Hopefully, I'll have a chance to come back to.
Yeah, I do want to get to them.
Usually, I find that people want to see the demonstration and stuff. So we're kind of known for flying by the seat of our pants with demos. So
Dan, one of the things that I kind of want to focus on and talk about is a little bit of the intersection of the data warehouse and Oracle Analytics Cloud, and what's
Yeah.
happening and how these tools do similar things. And we have a lot more overlap now. And what I'd like to do is just quickly show Spatial Studio. This is an interface to the Oracle database that are you monitoring chat, Dan?
Yeah, I'll take care of it. Go.
Yeah. So what we have is, this is actually something that we showed at the Analytics and Data Summit, but we have a client right now, Bowie State University, that's in the state of Maryland, just to give everybody a sense of where it is. It's in the, of course, I've timed out. Okay. Refresh. So here's Bowie State, here's the US, here's the Eastern Seaboard. It's kind of on the beltway between Washington, DC, on what they call the beltway, and it's halfway between Baltimore and DC.
And this is from the presentation that we gave at Analytics and Data Summit just a few weeks ago. So we're borrowing on that since it was presented.
Yeah. Here's where the students are. Huh?
Like normal, we've done more with it since then.
Yeah, well, it keeps evolving. We're doing it in Bowie's instance, so there's some interesting things happening with it. But in any case, you can see where the students are. The other thing that we'll do is we actually have brought in the census data. So these are census tracts, and these just to give everybody a sense of what data is available. This is publicly available data. This is all the set of columns that come from the US Census Bureau for each one of those tracts. So if you want to know about demographic information, ethnicity, poverty levels, what's the income per capita, all kinds of, how many houses people own, blah, 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 all that kind of stuff. This is publicly available. And what we've done is we've brought this data in so that we can do some interesting analysis. And what you see here, these are the raw data sets that we have. And then we programmatically built out a whole bunch of additional data sets based on the Spatial Studio tool. So for example, we can turn on the—
So Tim, wait a minute, every one of those outlines that I see is a census tract?
Yeah.
The orangish things? Okay, thank you.
Yeah, so this is one of the census tracts. I didn't turn the name on, but you can see that, the different statistics about it. Okay? Is that what you're asking, Dan?
Yep, that's what I was asking.
Okay. And so here we have, I can turn these guys off so it's a little easier to see. Here we have the students and we have the train lines. So the kind of thing that we're doing is we're actually doing an algorithm to see a nearness calculation in terms of distance to see which students are near the train, because there's a station right there on Bowie. Now, we've had several people point out, why aren't you using the stations instead of the track? I'm like, yep, that's obvious, but let me show you how you do this. So what we do is we just take the this bus train line and we say we want to run a spatial analysis. Now, this is the set of all of the analyses that are available. And you can see that there are many, many of them, and they're even more advanced, okay? And what I'm doing is I'm actually using the SDO within distance, this guy here. So when I have this, here's the train line, and then which layer am I going to filter? I'm actually going to filter on students, right? So I'm going to use this guy, and then, I can do distance in miles or whatnot, and then run it. I'm not going to run this because it takes a little time to run, but that's the general sense. And if you want more information on it, you can go to the actual documentation. Dan, I don't know how much of this you've read, but I think it's about 800 pages of
Not much.
documentation. So if you want to see the sequel and things like that of what it's running, you can actually come here and look at it.
So Tim, let me tie that back to what we're talking about while you
Yeah.
navigate. So what we talk about with an analytic warehouse is the ability to do these types of calculations.
Right.
It's all running off of the Oracle database in being able to see what are the students that are within 10 miles of this train line because we want to do some analysis on them. We consider that type of analysis to be an analytic warehouse type of analysis. And then you use tools like Spatial Studio that Tim is using to do all this calculation in the database where you typically have the heavy iron, and we keep the data in the data warehouse instead of moving it all around. Allow Spatial Studio to do this type of analysis in the database using database functions.
So this is just saying we want to look at urban, dense populations, and then where are the high schools that they may want that are close to Bowie. If we zoom out, we have other high schools that are not so close. And, so here's the set of high schools that are all the high schools, then the high schools that are closest. And if we zoom out, you'll see some of these are not as close. But we want to get a sense of where should they be targeting for, future students and whatnot. In any case, there's a lot you can do. The richness and the set of algorithms is very, very deep. What's happening with Oracle Analytics Cloud? Now, what we've done traditionally is we've kind of exported these as GeoJSON layers and then brought them in as custom layers, right? Yeah. But what we're finding now is that we can have native geometry columns as a part of a new attribute in OAC. Now, this is not released yet, so I don't know how much trouble I'm going to get into from Oracle for.
Nah, that's fine. They're fine with it.
They're fine.
They're fine.
So as you can see, this is a new symbol geometry. And what we've done is we've taken this same data, and you can see here we have some of the students, we have our census data. These exist as different layers within our map. So here, I think probably most people are familiar with the maps and how we can work with the different layers.
Well, hold on, Tim, let me just give a background on what you're looking at. You're looking now at Maryland. Tim's zoomed in to the portion. The red dot represents where Bowie State is. Now you can see the outline. The blue dots are the students that we were looking at before. And the difference is now, instead of looking at this with Spatial Studio, a GUI front end on top of the database, we're looking at it through Oracle Analytics Cloud. And Tim and I had a little bit of a debate on this. I submit that when you're doing analysis on this type of stuff and you're displaying it, you really should show this in Oracle Analytics Cloud, because that's where the business data is. That's where it lives. And we have things like, where is the student? What's their GPA? All sorts of business data that you don't have in Spatial Studio. So I would submit you should do all this type of visualization really in OAC, because that's where you have the combination of the map interface and the business data to actually color code this and do everything with it.
Yeah, so Dan, I hear you. I just think in terms of developing the maps and thinking through things, deciding what layers you want to bring in, what data sets. I mean, if you knew how many of the census tract stuff I looked at before I landed on what I was going to do. I mean, I hear you, but I start in Spatial Studio, okay? Because we have more power there. We're in the database. And it's creating the tables and the views such that I can now, this is just a connection. I don't know, this is not where I was going to go, but it might be interesting for people to see this. That actually cancel. No, let me do this. Let me just go to the data here. Okay. And here's the census data.
You're going into dangerous territory, brother.
Huh?
All right, you're going off script.
I'm going off script. So I just wanted to show that what I'm doing is this is coming in from actually instantiated it through a data flow.
Yeah.
Because it was a little bit, I was bringing in a lot of data. So here's this whole big census table. I kind of probably could have whacked it back. But at the end here, here's your geometry column. But this is very nice in OAC that you get a,
Wait,
you know,
go back.
thumbnail
Don't go back.
profile.
That
Sorry.
new capability of having a geometry type column is what's new in OAC. And we got a preview edition. They turned this on for us. By the way, it was publicly stated that if you wanted to have it, they can turn it on for your instance. And that's why we're talking about using this new capability that we're very excited by in the ability to natively handle in OAC columns of type geometry, which allows us to directly use these as maps and such in here.
Yeah. So let me go out of here and show you in the data, in the connections. So you can see that this census data is actually coming from a connection to an ADW. So that's what's so nice is we can develop in the develop in Spatial Studio in the ADW and then bring it directly into OAC. And we don't have to go through this GeoJSON custom layer. Let me go to the console, let me import and everything else, okay?
One of the new capabilities we have in OAC, and this is available for people now, is the ability to also do spatial calculations, such as within distance, that type of thing, to select things and such. You can create calculations. That's in there as well.
Okay, I didn't know you were going to bring that up.
Well, okay.
Just to
there it
show
is.
People these. So this is, you saw the big set of, I don't know, 30, 40 different algorithms that we have in Spatial Studio, and we go back and see, but this is the set that you have within OAC, okay?
And I would say they picked 6 that are the most used. And I know you'd say, yeah, I want more of them, but this is what we need. We should do it in OAC.
Yeah. So if we want to know how far away something is, we can, define one of these guys and then
calculate it. All right.
A distance.
We'll move
Anyway,
on to other stuff you wanted to show. Sorry, I led you astray.
No, sure. So
You want to show this in the database?
Yeah, no, I was just hang on. I gotta read. There's a problem when you go off script. You forget where you are. Okay, so what we're doing here, I just wanted to show that kind of one of the key things about having this publicly available data and having this ability to have a geometry column now, and this is back on the census data, is that we can actually use the data to, reveal different things about it. So this is just looking at census data and coloring by county, so that if we want to know about these census tracts and where are the county borders, we don't have to have necessarily a separate county layer. We can just use the fact that this county name or county, this is the name, so we can see it. We can also add all kinds of stuff into our tooltips. So if we wanted to look at the total population, this is super nice that we have both measures and attributes in here. If we wanted to see, the income per capita, total population, we can, and then you can also do combinations of things. We could do another layer where we set the transparency. I haven't done this for income per capita like we have on this guy, and then see through and see the color combinations by county. This is something we've done in a lot of maps, Dan, to kind of bring richness to it, and it can be very, very effective.
So
So
notice we have multiple layers that we can turn
yeah,
on and off with various
add
transparency,
layer.
all this type of stuff for doing
Yeah,
this type of displaying the maps. That's why we're so excited by being able to do this calculation directly in OAC.
yeah. So this is a second layer, and then if I wanted to do income per capita, I could do that. And then I could set the transparencies. And now we can, now we get the combination of the two.
Now,
Okay.
I want to make sure that we mention as well, it's great to show this takes a while to set up. You got to think through what you're doing. And the great thing is we can do that analysis and decide what to show. And
Yeah.
that's why we encourage people to play with the data and
Yes.
not design, and then say, now go implement. It really is a feedback loop where you're doing this as you work through the project. So we actually use the metaphor of a landscape garden of growing these types of analytic warehouses rather than a construction algorithm of putting in footings and building a house, because we think these things, these analytic warehouses, are designed to change over time. And so this is something where you can't just design it all from the beginning because you don't know what people are going to need from a business analysis standpoint, and you kind of feel your way through.
Yeah, Dan, that's an excellent point. The other thing I will say is that for a lot of times with the data shaping in particular, and the the work of what we need from a business case, we actually start in the front end.
Mm-hmm.
And then we work backwards, we work down, we push it down the stack, if you will, so that we get, greater efficiencies and faster processing. And we also necessarily kind of have a better sense of data governance and, let's make sure we go through a data validation process, those kinds of things. So we often have this flow back and forth between the different layers of the analytics system overall. And we find ourselves working in, doing similar things over again, if you will, but just bringing it back. So, and I kind of want to talk about that in terms of this. We looked at these different,
Yep.
here are the different types of data. I thought I had that somewhere else. I've signed out. Okay, never mind.
Well, let me make the point while we get the PC set. Now, we start with this in Oracle Analytics. So we often will expose it to Oracle Analytics. Once you do that, though, you need to think in terms of what are you going to do to push this down to the database. And there are times when we start with calculations, for instance, done in a report, we push it down to what's called the semantic model in Oracle Analytics. And then at times you want to then push that back to the data warehouse. And so Oracle has, as part of the analytic data warehouse tools, a set of tools that allow you to do this manipulation in the data warehouse, including, and I mentioned before, we talk about it, the ability to do some of this calculation in analytic views, a feature that's not used as much as it should in the real world. And that's what Bud's going to talk about in August, is doing these
Yeah,
definitions data warehouse.
yeah. If you want, I can show that, or you can
So
let
go ahead. You're going to go out.
but
Give me
what
the time to get this
what I was
up.
going to, yeah, what I was going to say, Dan, is that we have a lot of self-service tools, if you will, or business analyst type of tools now. We can call it a developer tool,
Mhm.
but there's a lot of capability for shaping and working with data. And what I would encourage everyone to do is to be very conscious of the schema design as you go through and you start using some of these self-service tools. The days of the DBA doesn't let you into the database and you have to threaten to putty in through a back door so you can get your work done, whatever. I think those days are, kind of coming to an end. And what we need to think about is how we set this, how we organize our access so that the important work can get done. It can get done using the tools that are available. So I just wanted to talk a little bit about database actions. So this is a suite of capabilities that are built into ADW that are very, very powerful and give us the ability now to work directly in the database. So as you can see here, we have everything from, you know, SQL worksheets to the data modeler tool, which allows you to, you know, basically build some stars or to do real, you know, database development in terms of tables and views and whatnot through a GUI. So it's a pretty cool tool. Some of the other, you know, obviously working with APIs and developing, you know, kind of the script base for the coders. You know, JSON objects or native object in Oracle database, so we can kind of flip back and forth, Dan, between a traditional table view and a JSON document view. So this is also extremely useful when we get into the idea of organizing our data, right? So I think this is very, very powerful. Charts just give us the ability to develop some things and do some profiling. I'm not a fan of this stuff, but anyway. You know, setting up, you know, kind of analytic workflows and processes. Now this is cool here where we get into actually doing the OML stuff, and I'll show some notebooks I have it teed up here. And then of course, Apex for real, you know, people that want to develop applications and develop, how do we move the data in and do something with it, and move it out and interact with other systems and do all kinds of cool, complex stuff. In fact, even with the maps, there's some very, very interesting capabilities in Apex. Graph Studio is the ability to work with data and the relationships between the entities in the database. So this is where we get into edges and nodes and vertices and
The point I wanted to make, I wanted you to go through all these, that's great. The point I wanted to make was all of these are native in the database itself. So you don't have to involve third party. Indeed, to make the point, you don't even need, you could do some of the analysis that you can do in Oracle Analytics, you can do in the database on that with analytic views and with Apex. But you get a richer set with Oracle Analytics Cloud. But they're in the database. You don't need some of these third-party tools that people are exporting out to and using. That allows you to create the analytic warehouse. Go ahead.
Yeah, so yeah, absolutely. The ability to get data in and out is much easier for a casual user now. I mean, the idea of, oh, just use RMAN. I mean, it's great for somebody who uses RMAN every day, but you know, as a casual user, having a specific interface to do this is really, really useful. This is the analytic view area, Dan.
Yep.
I mean, I can go back. Here we have different things. Let me go back here to the overview and just show you one that I've built. I mean, this is, we can go here, we can start to see, we can go into this stuff and find out what are the different components and whatnot of this cube. You can see it's set up as a cube. So some of this kind of capability is pretty interesting. And you know,
so let me just mention, Bud will go into this more in August, but in analytic view, if you're interested, is the ability to do analytic type of calculations in a view object that's designed for OLAP type of calculations,
right,
share calculations,
right.
and you know, change from year ago, all that type of stuff is built in, and then it allows you to use simple SQL as opposed to complex windowing functions, simple SQL to pull that data from your analytic warehouse and do calculations in the warehouse that otherwise would be very hard to write in SQL. Pages and pages of SQL that is simplified with the use of an analytic view.
So one of the things that I was going to mention, and I see we're running a little bit out of time, and I want to get back to the slides. When you're doing Oracle machine learning, you produce a lot of objects in the database. So you will actually, when you run when you actually train a model, you may produce 6, 8 different tables or view objects. And so kind of having them organized within a schema that's set up for that will help keep the other schemas organized as well. Through a lot of these tools, you can go back and forth to different schemas, so that if I wanted to look at my Spatial Studio user stuff, I can come down here, and then I'm going to have all the different, tables and objects that and again, Spatial Studio creates a lot of stuff too. So some of it's programmatic and just in terms of a SQL statement that it'll create, and some of it actually creates objects that are instantiated. So in any case, the data catalog becomes a very, very handy way to look at this as an alternative to SQL Developer or something like that. We can get a lot more information about it. Dan, we're gonna come back and do machine learning some other time, because I think we're out of time.
Yeah.
I was gonna show the movie script, but the movie stream star. I've timed out. So let me just go back to the slides.
Yeah, that's fine. And while you're flipping over, let me mention to people, I'll just mention, if you have some questions that we want to pose, put them in the Q&A widget. We'll come back to that after we kind of wrap up here and try and answer some questions that you all may have on this topic.
So we just have some general recommendations for why you would want to kind of organize your schemas certain way. And this is for, thinking about analytics. Recognize that sometimes we're saying, different things. So machine learning and data mining, they like wide tables, okay? Whereas if you're doing, kind of OLAP-y, analytic view stuff, and particularly if you're trying to analyze data and bring it together, you're going to prefer star schemas versus third normal form. So it's kind of like, here's third normal form, here's big, wide, flat tables. I mean, we do all of these for different reasons, and it's okay. And we shouldn't feel constrained by a particular take on working in the database. We need to, it's kind of horses for courses. We do want to suggest that, the rules, with data warehouses are often complicated, but what we want to do is kind of focus on that, analytics purpose. So, we want to think about these exceptions, these flag filters, all these kind of things. Do we want to create views that are easier for people to use, easier for people to consume as an analyst directly in the database?
And we have also, let me make a point here. We have also emphasized that in an analytic warehouse, and this drives some people nuts, we tend to want to look at the data as being directionally important. And sometimes some of these exceptions that drive the design of a data warehouse and make something overly complex, make it so that you can't do the analysis that you want to do. And so if normally it's a one-to-many relationship, but occasionally there's a many-to-many relationship, consider whether you can transform it to make it one-to-many, because that's going to make it easier for people to understand and avoid the many-to-many that is a truly an edge case. Design it for the real intended purpose of all the edge cases.
I know I'm driving a lot of people crazy right now, and they're probably saying, Tim, this doesn't, this is not how we do things in a professional way. I know, right. I understand. What I'm suggesting is that you allow your developers to have this kind of flexibility, but you organize it by schema, and you organize it in terms of, kind of that 6S, Dan, or the 5S, where we recognize we're going to create messes. We got to go back and clean them up afterwards.
Yep.
But, and what we want to do is we want to think about the classifications, and we want to share a framework in terms of how to organize your data and how to think about it. So I kind of want to walk through this a little bit, if that's okay.
Yeah.
All right. And what we have here is thinking about the data along basically 5 different dimensions. That we think about its availability, or its cold storage, if you will. That if we think about these dimensions, we want to make sure that we're aware if it's clean, modeled, governed, enriched, that kind of thing. So let me just go to an example. It's probably easiest to look at it. And that is, how available is the data? Is it in storage or is it in memory? So this also gets directly to data size. And I know everybody thinks that we can have trillions of data available at a snap of a fingers. Yes, no, not really, okay? We still need to think about this conceptually as we're scaling and deciding how to architect our data structures and our architectural structures. In terms of modeling, we have a continuum. You can see each one of these is a gradient from non-conformed and inconsistent, if you will, to conformed and consistent. So Dan, if we think about dimensions, we often talk about having conformed dimensions, right? For star schemas and whatnot.
Right.
Why? Because we want to be able to use those dimensions across different fact tables and combine the data, join the data, and have it be have it make sense and be available. Now, so this is something else we need, not cleaned and validated versus cleaned and validated. I'll tell you, with machine learning, sometimes you want, the raw data, sometimes you want it clean so that you're not, introducing noise into the system. And then we can think about just raw data versus enriched data, okay? So let me give a couple examples. So here we have one. How would we characterize typical ERP transactional data? The idea is that it is that is available, because the transactional system is, handling all these transactions all the time. It is, in terms of modeling, not always modeled. That's not its purpose. Its purpose is to do inserts and updates and deletes and all that kind of thing. Is it, how governed is it? They may think it's over here, right? The people doing the application implementations. And unless they have a really strong governance process, it probably is not.
Whatever somebody typed in.
Whatever somebody typed in. And I would say this also directly correlates with the age and size of the organization.
Yeah.
In terms of how much technical debt they have and how many different systems and whatnot. And then, is it enriched or not? Obviously, this is transactional data is kind of raw. Curated BI data, you can see that's highly available, highly modeled, highly governed, and sometimes can be enriched. But it takes a lot of it. This is really expensive data. We have to put a lot of process around this. And so we need to recognize that this is the most important data. That's why it's high on all these things. Self-service BI data, if you will. So a lot of times it's, stuck in one person's, area. It's not as available. It may not be. Probably if it's self-service, not really good on the modeling. Governance is probably really low, but it may be highly, highly enriched. So you may have an analyst doing all kinds of cool, forecasting and whatnot, but we just need to recognize kind of, the nature of this data. Scoring model data here, it's highly enriched, it's mostly governed and modeled, may not be so available. So the idea, Dan, is really that we want people to think through, what types of data are they working with in the analytics system? Are they working with in the warehouse? And how do we how do we organize and think about those in a comprehensive way? I don't know if we have any questions.
No, I didn't see any in there, but I'll go ahead and mention, as I said before, this is in a series of tech casts. We have the one coming up that Roger Cressy will be talking about advancements in S-Base. It's taking place in another few weeks. And so we're looking forward to that. And then we wanted to highlight the one in August that Bud Endress will be talking about. We'll be having fewer of these in the over the summer. But if you have questions, we'd love to talk to you. Reach out to us on LinkedIn. There's the email addresses, dvlamis or tvlamis@hcg.com. And we love to talk about this stuff. This is why we're passionate about it in terms of data warehouse design, analytic warehouse design, analytics, and so forth. Would love to chat with you more about this. Reach out to us, LinkedIn or here, or ask questions. We got a couple minutes left, but thank you so much for joining.
Yeah, thanks everyone.
Couple minutes. Anything else, Tim?
Well, I just want to wish everybody good luck, and know that there are a lot of overlapping tools and capabilities, and this is a good thing, not a bad thing. So, thank you, Oracle. So.
All right. Well, thank you, everybody. We'll talk to you more on another TechCast. If you're interested in this, see the TechCast page, and as well, just quick plug, I forgot to put it on there, but if you're interested in being involved in the AnDOUC, we have a welcome to AnDOUC TechCast taking place actually on Tuesday. Reach out to me. I'd love to tell you more about how we run the user community and such. So thank you, everybody.
Thank you.